1 from the homework tells us to evaluate when x equals 2, the function f of x is equal to negative 2x plus 4. Okay, so we want to evaluate f of 2. So we're going to write f of 2 is equal to negative 2 times 2 plus 4. All right? Negative 2, sorry, this is positive 2 that we're plugging in. Negative 2 times positive 2 is negative 4. And negative 4 plus 4 is 0. So I have 0 here. Negative 2 times 2 is 4, and negative 4 plus positive 4 is 0. So we've got our answer. Okay, problem number 2 asks us to evaluate when x equals negative 6, f of x, in this case, is equal to the absolute value of x minus 2. So to evaluate an absolute value, we simply plug in the value of x. So we have negative 6 minus 2. We do everything that we would normally do, and then at the very end, we make the answer negative. You don't change any rules. The only thing you do is at the very end, you make the answer positive. The answer cannot be negative at the end. You make it positive. That's what absolute value is. So negative 6 minus 2 is negative 8. We want the absolute value of negative 8. Well, absolute value can only be positive. It's the distance from 0. So the absolute value of negative 8 is positive 8. F of negative 6 is positive 8. It's positive 8 here. Okay, problem number 5 from the homework. We have x over 2 plus x over 3 plus negative x over 4 is equal to 12. So we have to find our least common multiple of 2, 3, and 4, which is going to be 12. So we're going to multiply everything in this problem by 12. Remember, you have to multiply both sides, everything in the problem, by 12. So 12 divided by 2 is 6. 6 times x is 6x. 12 divided by 3 is 4. 4 times x is 4x. 12 divided by 4 is 3. 3 times negative x is negative 3x. 12 times 12 is 144. Okay, 6x plus 4x is 10x, minus 3x is equal to 144. This is 7x is equal to 144. Divide both sides by 7. X equals 144 over 7, which is approximately 20.57. Record. All right. On problem number 6 from the homework, problem number 6 says x squared minus 2.5x plus 1 equals 0. Well, we know that this is a quadratic equation. It has an x squared in it. And we know that to solve a quadratic, we have two methods. We could use the quadratic formula, which always works, or we could attempt to factor the problem. Now, we have a decimal here. We know that we're not going to be able to factor it the way that we're used to with a decimal. So let's see if we can get rid of the decimal. Well, is there anything that all of the coefficients have in common? Let's see. This coefficient's 1. Because if you don't see anything, it's always 1. What do 1, negative 2.5, and 1 have in common? If we think about this like money, we know that they have 0.5 in common. 50 cents. So 50 cents times 2 is $1. So we've got 2x squared. 0.5, or 50 cents, times negative 5 would give me negative 2.5. And 0.5 times 2 again would give me 1. And this is equal to 1. So now we're going to take this new quadratic and see if it's factorable. Factoring's often much quicker and easier than the quadratic formula. So it's often easiest to try to factor first before we work with the quadratic formula. Okay, so we have 2x squared and 2. 2x squared times 2 is 4x squared. And they add to the bx term, which in this case is negative 5x. So we have to ask ourselves, what multiplies to 4x squared and adds to negative 5x? Well, if it multiplies to a positive and adds to a negative, they both have to be negative. So it's going to be negative 4x and negative x. So, negative 4x, negative x. All right, 2 and negative 4x, they have a 2 in common. Two x squared and negative x, they have an x in common. 2x squared and negative 4x, 2x in common. Negative x and 2, they have a 1 in common. Now we need to check it. Is 1 times 2, 2? Yes. Is 1 times x negative x? No. So we need a negative. Now let's go back. Is negative 1 times 2 positive 2? Nope. So we're going to have to put another negative here. Now let's check. Negative 2 times negative 1 is positive 2. Negative 2 times 2x is negative 4x. X times 2x is 2x squared. X times negative 1 is negative x. So we're good. So we have 2x minus 1 times x minus 2. Don't forget our 0.5 from the beginning that we factored out our GCF. And all of that equals 0. So now we can use our zero product property to figure out what x equals. So we have 2x minus 1 equals 0, and x minus 2 equals 0. Well, we're going to add 1 to each side, which gives me 2x equals 1. I'm going to divide both sides by 2, since 2 is multiplied by the x. And in the end, I get x equals 1/2. X equals 1/2. Now over here, I'm going to add 2 to both sides to get x equals 2. So x could be positive 2 or x could be positive 1/2. Okay, problem number 9 from the homework states the square root of 2x plus 5 is equal to 10. Now, we want to solve this. We know that we have to get rid of this square root. And to get rid of it, we have to undo it. Well, just like we undo multiplication with division and addition with subtraction, we undo a square root with a square. Whatever we do to one side, we have to do to the other. So we're going to multiply both sides. Sorry, we're going to square both sides. Multiply both sides by themselves. That's what I meant to say. So to square this, all a square root and a square do is undo one another. So we're left with 2x plus 5 is equal to 10 squared. Well, 10 squared is 10 times 10, which is 100. Now, this is a very simple problem. Subtract 5 from each side. We have 2x is equal to 95. We're going to divide both sides by 2, since the 2 is multiplied by the x, to get x equals 95 divided by 2 is 47.5. 47.5.